Hello everyone. Today myself Pranjal Verma, solution specialist in water and wastewater from Capricorn Technology, bring you to a weekly insight on how to perform a criticality and segmentation in WaterGEM Connect edition. So Capricorn Technology is a Win Zero company having a legacy of over 3 decades, has now become a partner of choice for the AEC industries. Capricorn Technology is one of the biggest platinum partner of Autodesk and Bentley, along with authorized training centers. So today, with over 10 offices across India and 220 inspired team members, we are serving over 20,000 customers in the building, infrastructure, manufacturing, along with a large number of other industries as well. So in today weekly insight, these are some of the features of performing a criticality and segmentation, like how we are gonna start with a criticality manager, and also for the same how to set up the segmentation. The next thing we are going to cover is how to highlight the segmentation, and also with that how to perform a outage analysis, and at the last how to run a critical analysis. So basically, the user can shut down the individual segment of the system and the result on the system performance are determined. So rather than having to do this through the scenario manager, the user will be able to simulate the set of outages in a single run. So this set can vary from a single element to each possible segment in a large element. The WaterGem Connect addition reports a variety of indicators for each outage during a criticality analysis. So depending on the type of run, criticality analysis can report the flow shortfall, volume shortfall, or pressure shortfall in the distribution system for each segment outage. Before being able to conduct a criticality analysis within a distribution network, WaterGem Connect Edition must identify the segment to be removed from the service. Once the option have been set up in criticality studies level of the segmentation and criticality manager. So the user decided which scenario is to be used for the analysis and set the reserve rules for use of valving in the option tabs. So in order to use the criticality analysis, the user must make several decisions on the way that WaterGem Connect perform the analysis. For the same, in today's video, we will learn how Bentley WaterGem help you to create a criticality and segmentation. So I'm just switching on toward the software and give you a live demo like how we can perform a criticality analysis. So let's suppose this is my sample of water distribution network, and we have to provide criticality and set up the segmentation within this network. So first, what we have to do is we going to start with the criticality manager and set up the segmentation. For that, what we have to do is we have to go to the analysis tab, and by clicking on analysis tab, there is an option as criticality. Just click on it. So this type of dialog box will be appear. Then what we have to do is please make sure that the checkbox should be correct for the considered valve in critical pipe segment analysis. Now what I'm going to do is I'm going to click new scenario in add scenario, and here this type of dialog box will be appear. From here we have to click on average daily demand and click OK. So this type of dialog box will be appear. From here select the entire network from the scope type. I'm just selecting an entire network from the scope type and just compute the result. This type of dialog box will be appear. If you have to just click on yes option. Yeah, so this type of dialog box will be appear. So here are the labels. So the list of segment is being identified. So in this case we have checked the considered board was checked. So the segment consists of variety of pipes and nodes. Now what next I'm going to do is I'm going to highlight the segment to view the color coded segment in the drawing. So how we are going to highlight the segment? So here is the option for highlighting the segment. As I click on this segment, so we can see within our distribution network, the segment has been highlighted. So the result of the segment can be advantageous. You can identify which segment requires successful operation of a large number of valves in order to achieve a shutdown. What next I'm going to do is I'm just going to bring back that table. Yeah. So what next I'm going to do is just right click on the isolation node here, just right click it and sort it according to descending. So as I sort it to the descending, so the segment I'm just maximizing. Yeah, the, the segment at the top of the list usually prove to be the most difficult to isolate and may require investigation to make them less susceptible to issue that arises due to inoperative valve. I'm just gonna minimize this. Yeah. So the next thing what I'm going to do is I'm going to perform an outage analysis to identify if isolating a segment causes other segment to be isolated. So for that what we have to do is just I'm linking back that table. Yeah. Now I'm going to click on the outage segment. As I click on the outage segment, it's showing nothing. So I'm just going to compute the result. Clicking on the yes option. Yeah. So this type of dialog box will be appear for outage segment analysis. So now what I'm going to do is I'm going to right click on the outage set length and sort it descending to find out which segment have outage that will cause a significant downstream outage. So how we can do this is I'm just gonna right click on outage and sort it according to descending. So outage segment 15 as we can show within the table, this segment is showing that it will cause a significant downstream outages. Now what we wanted to know that if we wanted to know that which outage has the highest outage set length from the label, just click highlight segment to view the color coded segment in the drawing. So let's suppose I have an outage segment 15 which is having a highest outage set length. I'm just gonna highlight the from label and just highlight the segment. So as we can show within our distribution network, to see that the pipe with the highest outage set length is in blue in color and the downstream outage segment that will be out of service are in red in color. Now what at the last I'm going to do is we have to also run a criticality analysis. So to run a criticality analysis that uses the hydraulic network engine to determine the impact of segment outage, what we have to do is I'm bringing back the table. Yeah, just highlight this criticality. uh, Check both this run hydraulic engine and compute it. Yes, so for the same criticality analysis as also has been done for the same within a distribution network. So for more videos and update, do subscribe our channel Capricorn Technology Private Limited and like and comment if you like the insight. We would be delighted to hear from you. Please reach out to us for any suggestion, query or topic you would want to discuss. See you next week. Thank you.